Okay. Before we start off officially, let me request someone to give us a prayer. If you're ready, you put up your hand, please. And then pray for us. Okay. Emma, you can unmute now.
Okay, let's believe and pray. Heavenly Father, in the mighty name of Jesus, Father, we thank you for this great day. We thank you for this moment. We thank you that you have made the minister of glory. Father, we ask of your grace, Father, to come and reign upon us this afternoon, that as we are going to attend this lesson, may you come and guide us, may you come and open our minds, may we be able to understand and coordinate with our teacher. We thank you and trust in Jesus' name. We do pray and believe. Amen.
Okay, thank you, Emma. Once again, I welcome you all here. I understand we are here to attend a physics lesson, senior 2. And we have had a number of lessons, about 4 of them in the previous 4 weeks. But we are still proceeding with pressure. I welcome the teachers on board, teacher Ronald, Dongo, and teacher Peter and Soga are right there. So we shall proceed in that way, but before I request you to mute Emma. In case you're not saying anything, okay. But if you want to say something, then you need to put up your hand right there. Emma, you left your hand up, I think. You need to lower it. Okay, right there. Okay. As I said earlier, we are proceeding with a lesson of physics in that case. But before we start off fully, I have a question for you. Did you get the requirements I sent earlier this morning? By show of hands, you can talk to us such that we see. Did anyone receive them through WhatsApp or through the Padlets? Anyone? Or you can type in the chat so that we hear from you. Basically, what your view is there. Hello? Do you hear me, friends? I don't seem to see any response. Okay.
Yes, the voice is clear. Maybe they have not yet got the things. Emma has a question. Maybe he puts his hand up and puts it down. I don't know why.
Okay, but my question was, before we proceed, okay, Emma, a minute, I was asking whether you received the requirements I posted through WhatsApp and then the Padlet in the morning that we need for this lesson. Did you receive that message, Emma?
I'm not ready to receive any message, so I am not aware of what you required for this lesson.
Okay.
Teacher Jose, what we should do maybe, let us put the requirements. We give them around 5 minutes because they are not too difficult. Those ones who can get them, they get them so that we can start the lesson well.
Yes, okay. That's okay. Though I wanted to hear from them because there's a very important information to note right there. So they might not be able to get all of them here because last time we gave them an assignment. So it was a reminder as well through that post. They are given an assignment, but okay, let me take them through where I posted that work. Let me share my screen right here. Okay, when you come to the Padlet, okay, I will post the link again that we need, but for senior 2, I posted a timetable right there for this week. So January 1, then this is the post. Like I think I posted it at around 11 a.m. So when you click in it, it will open. And then you are required, first of all, to recall that you are given an assignment last Friday. And on that note, I didn't see any posts. Yet we had requested you to post your work and the solutions, because as we went through Friday's work lesson, we are noting, but I didn't see any post there for comments or marking. So maybe we need to hear from you. What's really the problem? Because we need to move together. So if you're finding any issues, you need to forward them in the minutes coming right there, such that we get your view and find a way forward. Then after reminding you, you are requested for this lesson to be with your research work, so that you're able to present. That is the requirement 1, your findings. That is to say, we need to hear from you what you did as per that take-home assignment we gave on Friday. You give us your view. And then after, for today's lesson, we shall need the requirements there for the section 2 and the lesson requirements. So that there we're having 2 right there. But the first one, and that will be our starting note to this afternoon, is for you to present your findings. Or if you have any issues concerning Padlets, then you need to put them forward. Otherwise, we need to move in a better direction with your posting, and then we comment or mark. That will yield something. Okay, so that was my post. I will find it under Padlet, that is senior 2. And we say that this column is for teachers to post. So your post will be under senior 2 assignment hand in Padlet, and you click in that picture where you see the nice forks and spoons right there. And then you will look out for the work of that day. So I've been doing the work, and those were the posts since we started. So last week was 27th. So I expected you to post work here. And I attached the link in the document, and I reminded you, I think, on Friday or Saturday, but I don't see any posts here. So that's why I say that we need to hear from you. The problems you're finding are moving forward. And then for today's work, we shall be posting here. And the link is attached as well, the document you are going to use. But not posting the document right now for the activities you're going to do this afternoon, because I need to hear from you what you really did, such that you post something along here before we move forward in that case. Okay, I need to stop.
There is a hand here for Mary Stella.
Okay.
Mary Stella, you say out what you want to say.
She doesn't have a mic. Maybe she needs to first log out, then she enters with audio. She needs to enter with audio. Yeah, right there.
Okay, Teacher Jesse.
Okay, friends, we need to hear from you. What was really the problem? Because we can't proceed this way without you posting anything. Okay. So in the chat, okay, Bella is just greeting us. Okay, Bella, we need to hear from you. What was really the problem? I don't seem to see any posts, and we need to address that before we move forward.
Sorry, sir, I have just joined.
Okay,
Okay.
fine.
Bella, how did you join? How did you get the link to this class? How did you join?
Someone sent me the timetable.
And then how did you access the link?
I think he used the meeting ID and...
Yeah, I used the meeting ID and the passcode.
Okay. Are you in our WhatsApp groups?
No?
Okay. We shall need to add you there. Okay. I need to look out for that post. Okay.
Someone says missed the lesson.
Someone said missed?
Yeah, missed the lesson that day.
Okay. But I don't know whether Heaven is in the WhatsApp groups. I posted the document again on Saturday and reminded them. Lawrence, do you want to say something?
I also missed the lesson last time. I was not around.
Okay. The good thing you won't miss this afternoon. Hope you have the network.
For those who attended the lesson,
I remember some people here. We had Emma, we had Benjamin last time. Okay.
Yeah, for those, Teacher Jose.
Yes.
For those who attended the lesson, they should tell us the challenges they faced.
Yes.
That's the challenges that stopped them from posting the work on the Padlet so that we can help them. And then we catch up with this new group, these ones who have just joined us.
Yes.
Yeah, if you attended the lesson last time, please, in the chat, you put what challenge did you face that stopped you from posting work in the Padlet, because we want to help you put the work there, not to criticize you for not putting it there. So just tell us which challenges you faced to put work on the Padlet, then we can answer the challenges so that at least we start the lesson when there is some work in there. You just have to take pictures of what you were writing and then you post it there. So if you attended last time's lesson, please tell us which challenges you faced. We are here to help you out. Those ones who have just come, you settle in. We are going to be telling you how to put work on the Padlet. And therefore, after, we'll be going on with our lesson. But we want to help those people who were there so that they can post some work.
Okay, Teacher Peter, thank you for that. I'm posting, if they missed, I'm posting the link to the Padlet. If maybe they took the pictures and they didn't post. So you can tap on the link. Okay, let me show you how we use that. Maybe, let me share my screen. The link I have just posted in the chat, okay? Just come to the chat, okay? Click on the link. It will take you right away to the Padlet you are talking about, okay? You'll be able to see all our posts, and all the posts I made are here. So this is the work for last time. And as well, I posted in the WhatsApp groups right there. But for you need to post along senior 2 assignment handling. You click in those beautiful tools right there, the forks and spoons. Then the homework sheet will open, and then look out for that day's work or section. Okay, so for Friday, we are supposed to submit along in the section of 27th. How do you submit? You click on that plus sign. Okay, if you don't have the app, you can download it from App Store or Google Play Store. Okay, and then after downloading it, you can sign in using your Gmail account, and then you'll be able to access all the links you attached to. If you find issues joining through the app, you can use these links and then click the like button. The like button is kind of a heart icon right there, like the one I have above there. After homework sheet 4, there's that next heart icon there. So when you click on the plus sign, you'll be able to type. If maybe you entered as anonymous, maybe using your computer or laptop and you don't have the app, you can type your name here. Say Joseph's work. You can type Joseph's work. Joseph's work. Then if you took a picture, there's those icons. There are those icons after cancel. There's one with a picture and then mountains kind of. When you click on that, it will take you to the gallery. And then you'll be able to post anything. You can click any picture right there. It will load, okay? And then the post icon will pop up and you click post. Simple as that. And then your work will be under that section, okay? It will be under that section. And for today, you do the same right here. You take your pictures and then upload. In that case, you click on the plus sign and upload. But because I didn't mean to post this, or if you want to edit, you click on those 3 vertical dots on your upper right corner. Click on them. You can edit, you can transfer, you can delete. So I will delete right away because that is your section for you to post right there. So that is what you are supposed to do simply.
Teacher Jose?
To post in the public. Yes, please.
I've seen some people in the chat. Someone says he faced a problem of finding the mass of water, which he had to use to find the weight of water. That was Chigundu. So I don't know how we are going to help him.
Okay, maybe.
Then another one, Faith. Faith says she actually didn't do the work because she didn't get it well, I think. Okay. Maybe we revisit. Let me use that link again. Okay. And let me share my screen. So that I go right away to that document. Okay. I come to the chat. I hope you're seeing my screen, friends. It can be seen.
Okay. I click on that link I posted right there. The Padlets will open. Then it will bring you to the section. Then look at that physics section. Run through and see what we have been posting. For weeks, we have been posting a lot of work. Yeah, from day 1. That was on 9th. But the current work is right above here. And as I said, this is what I posted this morning, 30th August. But there was this work, the activities. When you click in that, okay, let me start with Benjamin. Now, Faith, you know how to access the work right here. Now, Benjamin is saying that he wasn't able to find the mass. But remember, we said that under task 5, after finding the volume of water, okay, volume is length times width, base length and width, and then the height of water raised in that case. And if you used a jerry can, you could fill it, and then we showed you the conversions where I say that 1 liter equals 1,000 cubic centimeters. And then in cubic meters, that was 0.001 a liter. So if you're having 5 liters, then you multiply 5 times 0.001 cubic meters, okay? If you use the jerry can. If you used a 10-liter jerry can, again, you multiply. And then you find your volume there. So after finding the volume, you are given the density. The density is 1,000 kilogram per meter cubed. And since you have already your volume in meters cubed, then you could multiply, because from the formula density equals mass out of volume, you could make mass the subject, say that you have density times volume. You find the mass right there. So after finding mass, you could find the weight, but you get weight from the force. And by converting A for G, where G is acceleration due to gravity, I will take you through that again. Then you could have the mass you obtained earlier under task 5 and multiply it times 10. Times 10 meters per second square. And then I obtain weight. Then from the formula, pressure equals a force out of area. Now your force will be the weight now, but you have obtained the weight already from mass times 10, where 10 is acceleration due to gravity. Then over area, that will be the best area you have above. The best area you have above under task, was that task 3? Task 2, right there. You divide and then find the pressure. It was as simple as that. Okay, let me hope Benjamin is okay now. Okay, Faith is saying she needs the Padlet link. Okay, let me repost it right here. Let me repost it right there. So that is the link. So friends, we are spending a lot of time here because Samuel, please mute if you're not saying something related to what we have here. So friends, we are spending a lot of time here because we want you to post something and then we give you feedback. That will be very important for you to understand what you are discussing right here. But if you don't post, I won't get to know what your problems are and won't be able to help you. That's why we are spending all this time right here. Any other problems? Teacher Peter, do you seem to see any other?
No, I think they have got what to do. We'll just wait for them to start posting, maybe as we continue with today's lesson. We see if these people can continue to send their work, but as per now, I don't see any problem or challenge because the ones we had have been answered The one who wants links to the Padlet has been given. So I think we...
Then the other thing, maybe we need to share as well for our friends here who are new, need to share the WhatsApp links. Say that they join.
Who are not in.
Yes. I don't know whether you can look out for them right there as I attend to our friends here. Okay, Faith, unmute, your hand is up.
Sir, I would like to ask, like, if we are not in the WhatsApp group, how do we get the link?
The link to what?
Okay, like for sending the exercise
No.
we have done.
Faith, did you see the link I posted?
Yes.
In the chat? That's the same link we use. Okay. If you want to post anything, just tap on that. Okay. You can copy it for now. But are you using a phone or a laptop?
A laptop.
Okay. You can have that link captured such that you always log in and then submit.
Right.
But if you can as well access a phone, you can download the app. But you shouldn't get worried if you, I think we shall need to find a link to the staff group such that you get the information. You get the information. Angel, which are you talking about? For the Padlet or what? You need to unmute.
For the Padlet.
Okay. So, okay. Okay, for the Padlet, it's right there. It's right there. Okay, someone is asking for the requirements for this lesson. That was gift. Okay, gift. We had I don't know whether you knew, but your friends here we are given an assignment. Okay, we are given an assignment. Okay, but we would want to first hear from them what they did. But if you need the requirements right now and you're not in the WhatsApp groups because we posted them earlier, just click on that link. Let me take you through once again, maybe lastly. Let me take you through using that link. Okay, come to the chat. Click on that link I have posted with padlet.com. When you click on it, it will open in the Padlet you're talking about. Okay, then look out for the post I made. There's a post I made this morning, the one having 3 hours ago. Okay, and I said, greetings friends for today's lesson, physics lesson at 2 p.m. Please be ready with the requirements listed above before the lesson. So when you click in that document, you'll be able to find the requirements. So the first requirement, because we are given the assignment last Friday, was to present what your findings were for that case. And that is our point of discussion right now. And we have only 10 minutes for our friends here to submit what they found. And if you missed, then you follow up as we discuss through. And then after, for our next discussion, we shall need the requirements listed under 2. And that will be a uniform cylindrical container. So it can be a glass, but uniform meaning with the same size from the bottom moving upwards. And then normal tap water, the water, you know, but it should be clean, and then a roller and then a garlic right there. So those are what we need basically this afternoon. Okay. Any other concern, friends? We need to hear from you what your findings were in that case. Okay, I'm posting the WhatsApp group link, right now, such that our friends here who have just joined us can just join in now. Please use that link to join now. Just click on it and then click join.
This is S2B?
Yes.
Okay.
So that they don't miss out. Please just click on it and join as soon as possible right now. Okay. In 5 minutes, friends, did you really do the work or you didn't? We need to be honest.
I didn't do it.
The link is?
I didn't do it.
Okay. Faith is saying she didn't do. Because we need to frankly hear from you such that we know how to proceed. David, do you want to say something?
Joel says he didn't do the work. I think most of them didn't do the work, according to what I'm seeing in the chat.
That's unfortunate because, friends, you should dare to do the work if it is given, so that we know how to move forward. Okay, someone is saying that they have schoolwork. Okay. All right, teacher Peter. Because
yes.
I want to spend. Okay, Edwin is saying the budget is too slow. Maybe that is because of network. Then someone is saying, I just joined. Use the links, please, to join the WhatsApp groups and then the Padlet there. Don't miss out this time. I didn't cause, I just joined. Yes, Trevor. Please use the links above. Let me repost them. The one for the Padlet and then the WhatsApp groups, so that you don't miss out anymore on any communications. There. Okay, teacher Peter, because our friends here didn't do the work. Okay, I think for now we can proceed, but friends, next time they do the work because it is very important. Otherwise, we won't be moving forward in that case. Okay, so I had prepared today's work such that after hearing from you, the feedback, as in the research you made, I could post the work such that we harmonize what your research was, such that we move forward. But because you didn't make any progress, let me now share the work. I'm going to first post the work in the WhatsApp group first, and then in the Padlet, and then in the Padlet such that we are able to access it right there. So those of you who joined our WhatsApp.
Excuse.
Yes, please.
How can how can we get the WhatsApp link?
The WhatsApp link is in the chat already. You check the chat. It is there.
Do you know how to access the chat?
Yes.
Yes.
I've put it there. You can see it now.
Look out for those links.
Put the one for WhatsApp group and then for the Padlet for those ones who need to hand in their work.
Yes.
Okay, Teacher Jose, let us see what we have for today before time goes too much for us.
Okay. Okay, for now, Teacher Peter, I request you to communicate to Teacher Winnie such that she opens up the class, the senior 2 class for posts. Yes, otherwise, okay, let me use now the Padlet as Teacher Peter is doing so. Let me upload today's work in a minute. Okay, I will first give it a heading, physics lesson on 30th, because I wanted to post this after hearing from you what you really did. But for now, let's proceed. Let's proceed. Okay, a minute, friends. A minute, because, okay, I think our friend here said the Padres are slow. I am also experiencing that. So for now, I might not be able to.
Maybe for now we can just share.
Yes.
The screen. We follow procedures with them, then we'll put it later.
Yes, let me do that in a minute. Let me hope Teacher Winnie will as well open the class, that is senior 2, such that you're able to post in there. But a minute, I need to do something here. I need to do some things here. Teacher Peter, someone seems to be saying something.
I had just joined in and he hadn't muted his microphone.
Okay. 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 A minute, I will be there in a minute. Okay. Right there. Let's start from that point. Because we need to review, but we have done a lot about the review. So for the past 4 weeks, I've been discussing pressure, and we did look at the questions and a few calculations under minimum and maximum area. We looked at how we can determine the pressure exerted by a battery cell. That was last Friday. And then we looked at how we can determine the pressure exerted by water in a uniform cuboidal container. And that was last week as well. So the assignment was given for you to look out and Benjamin is saying, okay, I look at that. So the assignment was for you to give us the procedures or findings of how we can calculate pressure for water or fluid in a cylindrical, uniform cylindrical container right there. And we say that for uniform, you're talking about same size, okay? That container or glass or anything should be of the same size from the bottom to the top. So under the requirements, that was 2, we looked at the requirements. You are requested to look out for those cylindrical, uniform cylindrical containers, and we gave examples. We gave examples of a bucket, a pail, or a glass, but they should be cylindrical or uniform. And cylindrical, we mean that they are first, if you're dealing with 2 dimensions, they should be in a circular form. Then in 3 dimensions, they should be cylindrical, like the glass you're seeing right there. So as we move forward, let me request someone to read for us what we have right there. Anyone ready to read for us? You put up your hand.
Yes,
Okay,
there
Faith.
is Faith.
Okay, Faith.
Task 1, pressure exerted by water in a uniform cylindrical container. Task 1, present your research findings for the take-home assignment given in the previous lesson. Using a uniform cylindrical container filled with water to a height h, describe how you can determine pressure exerted by water in this container in Newton square meter. Assumption,
Okay.
the weight
There is a meter squared.
Per means you're dividing, you're having area in the denominator, okay? That's that kind of negative bit of it, but it means per or inverse in that case. If you looked at indices under math or in math there. Okay, the assumption, Faith?
The weight of your container is negligible.
Okay, a minute there before you head to task 2. So we are supposed to look at that first in the first 40 minutes, such that we discuss through what your findings were, such that we harmonize now with task 2. Okay, but because we didn't do that, we shall go through now task 2 and not everything. Friends, have a book and a note, because after, in the last 30 minutes, we shall need to post the work in the Padlet. So not everything as we move forward. Okay, task 2. Faith.
Compare your findings with the procedures listed below to harmonize your research. Procedure 1, look out for a uniform cylindrical container in your home or in your reach. For example, a uniform cylindrical cup, glass, bucket, pail.
Okay,
2,
a minute, Faith. Are you able, friends, to have either of the 4? Are you able to get one of the 4? If you are able, you put up your hand, because we need to use them to proceed. If you're able, you put up your hand. Don't open your mic, just put up your hand. If you're able to get a uniform cylindrical cup, it can be a plastic cup, okay? Remember those plastic cups, the nice cups? Yes, those ones, or you can have a glass. Uniform meaning it is of the same size from the top, from the bottom and then upwards. Or a bucket, uniform again, or a pail. Any. If you're able to get them, you put up your hand. One of the, you need just one of them. Okay, we have 3 hands.
I'm seeing 3 hands.
Okay. Your friends as well, look out for
now. Teacher Jose.
Yes, please.
How is it if they can get a water bottle and they cut off the top? Is it?
Now, the problem we have with that is the that water bottle might not be uniform. Like, look at the Renzori bottle.
Oh,
okay?
I see it.
It is not uniform.
Eh?
Yes. So we need a uniform because you won't be able to account for the deformation we have inside there. Yes. So we need a uniform. Say that way.
I'm seeing 8 hands already.
Okay, that's a good number so far. Let's request other friends to be looking for them because we need them for these activities. Okay. Since you have them, okay, you have a demonstration of what you are going to do right there. So we are going to be using water. That's why we needed normal tap water. Use some clean water. Because as well, we shall request you to take a clear photograph and then you post in the Padlet right there. Okay. Faith, are you reading for us again?
As you can lower your hand, it's okay.
Okay. Let's proceed to 2.
Using a ruler and the base of your uniform cylindrical container, measure the diameter of the base thrice and record the results in the table as shown below.
Okay. Thrice, we are saying 3 times. We went through what we need to do right there, but let me go through it once again. Because we said that if you have your uniform cylindrical container, okay? Okay, let me do something here. Let me hope that I'll be able to draw something cylindrical a little bit. Sorry about the stuff there, but consider it cylindrical. And you're looking at it from the bottom, right? Okay? So what do we need a ruler for? Get your ruler. If say this is your center right there, get your ruler and then press it there. Press your 0 mark right there and then measure. Oh, sorry. But let me hope you get a picture of what you are doing and then measure through. And then where you have that mark there, you record. That will be your D1 in centimeters because you're using a ruler, but you should give to 1 decimal place, okay? Say if your bucket is, how many? 16.4 centimeters, the diameter. That's what you write to 1 decimal place. If you're having a cup and it has maybe 5.1, you write to 1 decimal place, okay? And then you proceed. If you're having a glass, then you do the same. Then the second time, you can take now this point, any other point, put your ruler there and then draw through the center you estimated last time. And then you take that mark at the edge of your container and then measure. Remember your 0 mark was there. Then measure, secondly, the line you have there. That will give you your D2. Again, 1 decimal place and in centimeters. Let me hope, friends, you're doing and recording your work. Then the third time, look out for another. From there, maybe, and then through the center, measure again up to there. And that will give you your D3 in centimeters to 1 decimal place. So you just look out for any dimensions running from 1 circumference point to another across. And then you do that. Measure and record to 1 decimal place. Let's hear from you. What have you recorded? What have you obtained if you have measured that case? If you have obtained something, you type in the chat or you tell us what you have obtained as your D1, D2, and then D3. Benjamin, we are recording to 1 decimal place. I don't know whether that was you meant to say 3.0. I don't know. Okay, Joy is saying 7 point, okay, 3.0. Joy is saying 7.6, okay, centimeters for now. Okay, you record them. Yes, you recorded them in the table right there. Okay, Cynthia 7.7, okay. So measure, yes, please.
I ask them as they even post in the chat, they should put the units there, because we faced a challenge when I was with the S3s. Some of them, because we reach a time and we want to convert units, and when they don't put units, some of them take that 8.2 or NS7 without changing units. They just take, and where we go there, we find it difficult for them to change. So they should put the centimeters there.
Yes, that is very important to note there.
Lawrence put 8.2 centimeters. Cynthia, please make it 7.7 centimeters. Chigundu, it has to be 3.0 centimeters. Don't just post like that.
Yes. For now, we are first measuring in centimeters. That is very important to note. That is very important to note. Okay, we have a minute to do that. You have a minute to do that, such that we proceed and such that we move forward.
Teacher Jose?
Yes, please.
I think the S2 WhatsApp group is open. If you have some time on you can put there.
Yes, that's what I'm doing right now. I have posted in group 1. I have posted in group 1. You can easily access what you are doing. And then in group 2, I'm doing that in a minute. I'm doing that in a minute. Okay, for group 2 as well. Group 2. Okay, Teacher Peter.
Yes.
Let me hope our friends here are through. I don't know how far they have gone. Okay, in group 2 as well, I have posted the work there, and there are links as well. You can always click on them. They will lead you to the pages right there. Okay, let me hope you have recorded. You have drawn the table there and recorded very well. Okay, Faith, are you proceeding with us reading?
Yes.
Read 3.
Using your measurements in 2 above, find the average diameter using the formula. Diameter is equals to diameter 1 plus diameter 2 plus diameter 3 divided by 3.
Okay, so friends, do that as well. Add the diameters you have obtained, the 3 of them. Then by average, you divide by their number, their 3. If you had 4, you divide by 4. Average is the same as mean. We looked at that last time as well. Okay, then 4
Using average diameter D in 3 above, obtain the radius R of the base of a uniform cylindrical container. Record this radius R in centimeters and then convert it to meters.
Okay. Okay, Gilbert in the chat is asking whether we need to use the top or the bottom. Either way, if your container is uniform, you can use either the top or bottom, though the bottom part is easier because it is filled. It is filled and you can easily trace the midpoint in that case because we measure the diameter through the midpoint right there. Okay, before they are saying using the diameter in 3, obtain the radius. How did you obtain the radius? Who remembers what we did last time? You put up your hand if you remember how.
Divide the diameter by 2.
Jose, are you on?
Teacher Peter, my network isn't stable. Please, I request you to give me co-host rates. I had dropped. I have network issues again this afternoon.
I think you are safe now. Yes, Patricia, you have your hand up. What might be the reason, dear? Patricia?
Radius equals diameter divided by 2.
Okay, we are telling us radius is equal to diameter divided by 2. Thank you for that, Patricia. Members, if you have been getting your radius,
okay,
you get it from diameter divided by 2 in centimeters.
Yes.
After you have got the answer in centimeters, may I see those answers flowing? You write radius is equal to, then you put your answer in centimeters in the chat.
Okay, so if you measured your diameter in centimeters, then you divide, find the radius in centimeters. Then how do you convert in meters? R in meters. R in meters. What do we do? Sorry about this. Sorry about this. R in meters. What do we do? Very fast. Okay, Emma.
Divide by 100.
Okay, we divide by 100. That's good. So if you have your, it depends now. Remember, we have different diameters. So divide by 100 and then convert to meters right there. Okay, we need to move. Need to move right away. Okay. That was 4. Then 5.
Calculate the area in meters squared of the base of a uniform cylindrical container using a formula. Area is equal to pi r squared, where r is radius and pi is 22 out of 7.
Okay, so friends, substitute. You have obtained your radius in meters. Substitute, find area. Let me hope, friends, you're recording doing everything because we are giving you time to do that. So you're recording somewhere, because after we shall request you to post your writings there. Basically the solutions, because we moved past presenting the procedures. Okay, let's move now to 6. To 6.
With a uniform cylindrical container resting on a leveled surface or table, pour normal clean tap water in it to a height h in centimeters and convert it to meters thereafter.
Okay, so put either your glass or your cup on a leveled surface. Okay, if you have a table, press on that. If you're using a floor, no problem, provided it is leveled. Okay, it is not inclined. Okay, what do I mean? You have you should be having something like this leveled. So this should be your surface now, and then you press your glass or cup right there. Okay, don't press it on an uninclined surface, something like that. No, leveled right there. Okay, let me hope, friends, you have done that. On the leveled surface, pour water. The other normal water I talked about to a certain level, depending on the container you're having. Okay, you won't determine you won't dictate on the level height you should pour your water to. Then we proceed to 7.
Calculate the volume of water V in a uniform cylindrical container from volume pi r squared h in meters cubed.
Yes. So we are measuring now volume. So sorry, we are calculating volume of water. Remember, now we know the height, but let me hope you know how you have measured the height. Okay, you're measuring height from the bottom where your water starts from now. To a point you have raised it. Okay, 2. That will be the height. But remember, we obtained already the area, the base area of our container already. So when you multiply the base area times height of water, that will give you a volume. And because we converted them in meters, then we shall record them in meters cubed right there. Okay, 8.
Given the density of water is 1,000 kilograms meters cubed, the mass of water is then obtained from mass is equals to density times volume, hence weight of water. W is obtained from W is equals to mass times acceleration due to gravity.
Okay, thank you, Faith. Muchongizi is saying he doesn't hear anything. Maybe it's your network. You can always log out and then join in there. Okay, Benjamin at the start asked that anyway, one of his problems were not being able to calculate the mass. So now you have the formula right away there. So if you have, because you're using now water, if you have the density of water or density of any other substance or fluid, and then times the volume, which you have already obtained above there, we can now obtain the mass from the formula right there. And after obtaining mass, let me use this space below to write. After obtaining mass, which is M, then I don't know the mass you have obtained. but depending on what you used or what you obtained as volume, depending on the container you're using. So if you know the mass from the formula, density times volume, okay, times volume, then you can obtain weight. And you looked at weight, the formula for weight last time, and we say that weight comes from force, because force F equals MA, okay, where A is mass, and then, sorry, where M is mass, and then A is acceleration. Now, when you substitute A, F for G, where G is acceleration due to gravity. Acceleration due to gravity, maybe you can ask yourselves, why is it that when I displace any body above the Earth's surface, it is pulled to the ground? So there is a force of gravity. And the way the body moves towards the surface of the Earth, it moves with an acceleration. And that acceleration is what we call acceleration due to gravity, G. Okay? So if you find weight written as mg, okay? G means acceleration due to gravity, not grams. So W now will be mg, where m is mass in kilograms. You obtained it earlier, right here. You obtained it earlier right there. Then G is given always, and it is a constant as 10 at O level, 10 meters per second squared, but at A level, it will be different a little bit. A lot of concepts will come in. But for now, we use 10 meters per second squared. So substitute the mass you obtained above under 8, and then times 10. You'll be able to obtain a weight right there. Okay. Let me hope. Yes, please.
I was suggesting those ones who have got answers for volume, mass, and weight can send them in the chat so that we can see their progress. You send volume, then mass, and then weight, and then we see in the chat. The other thing, Teacher Jose, is some may calculate their volumes, and on their calculators, they get what we call exponentials, times 10 power something. So some of them, instead of writing that one as part of the answer, they neglect it. We saw it in S3. People neglecting that. So I beg, if they calculate and they get times 10 power something, they should leave that one as part of the answer. Yes. So that we can get correct things. Because, you know, when we change to meters and then we divide by 1,000, we can't really miss getting those ones in the answers.
Yes.
So when they get them, they should keep them.
That's very important.
We can use them masao.
Very important to note right there. Thank you, Teacher Peter. So say, for example, if you got your volume, yes, let's talk about volume. I'm just giving an example. Maybe you got 1.234, and then times 10 using your scientific calculator. Times 10 power negative 5. Okay, meters cubed. Okay, so you should include that. Very important, because if you convert to now decimals, you need to divide now this number here. You divide that number there by what? 100,000. Yes, by 100,000. Because this the power there, which is 10 power negative 5, is the same as having 1 out of 10 power 5. So it's the same as a person who writes 1.234 times 1 out of 10 power 5. Remember, I said that negative means inverse. And 10 power 5 is the same as 100,000 right there. So you can divide and convert to decimals there. Very important to note. Thank you, Teacher Peter. Okay, do you have any answers in the chat so far?
Let me check and see.
Okay, we have Benjamin has 1.13 times 10 power negative 4 meters cubed. That is volume. Very good.
Benjamin, please don't forget units. There, you have to put units. Put units there because we need to know what we are dealing with. We want to see volume, we want to see mass, and then the weight.
Okay, in a minute, maybe they can do that in a minute because let me hope our other friends are following. Friends, we are discussing pressure. Those who came in late, we are discussing pressure. We have had a number of lessons. This is our 5th lesson. And we said that if you missed out for a number of lessons, we have our Padlets where you always post our work. Let me share the link. I won't get tired of sharing that link. It's very important there. So you always post our work. You always post our work in the Padlets. I'm sharing the link right away. There, that is the link. And if you have just come in and you didn't join our WhatsApp groups, I'm sharing the group link in a minute. Of course, you have two groups. The first one is full, but this one, for this one, we still have some space. And the link is right here. I'm posting it in a minute or in a sec right there. So those two links are Teacher Peter?
Now I'm seeing Arnold in the chat. Arnold still has his volume in centimeters cubed. That means he skipped that step where we had to change radius from centimeters to meters.
Yes. Teacher
But
Peter,
I think, yes?
My network this afternoon is a problem. I had dropped again, but I won't get tired of coming back.
Okay. Arnold, please. Okay, find a way of changing this volume to meters cubed. If you skipped the other, I think you multiply by, you divide, sorry, by, is it 10,000? Something like that. You check how to change from centimeters cubed to meters cubed. Teacher Jose, let me give you the host rights back.
Yes. Thank you. Thank you very much. Yes.
Yes, there is a person with the taking of BC3, you have your hand up. You tell me what the reason is. The one with taking of BC3, tell me what the reason is so that we can help you out. If there is nothing to say, then yes.
Please unmute. Taking out, but we also advise our friends here to always rename their devices. That's very important for us to identify them right there. Okay, maybe our friends, I don't know whether they are through because I had dropped, but
Mchunguzi has 3.74. Mchunguzi, you cut this one to 3.741 times 10 power negative 3, and the answer is meters cubed.
If that is, he's talking about mass. Mass is in kilograms.
Mass is kilograms. Sorry, I had not seen that. Kilograms. Mass is in kilograms, please.
Muchunguzi, please round off that number to 3 decimal places so that you have 3.741 times 10, excuse me, times 10 power negative 3. If that is the mass, kilograms there. Okay, Trace is saying we are trying to find volume. Okay, we shall give you time to finish up, no problem.
So there is the person with taking of BC3 as he's saying that he's lost somewhere, but if he can write in the chat, I will answer him because he has failed to ask here.
Okay. I think for now we can proceed.
Neglecting the weight.
Okay.
Neglecting the weight of the container with water, pressure exerted by water in a uniform cylindrical container on a leveled surface or table is obtained from pressure is equals to weight of water divided by base area. Task 3, using your measurements of diameter and radius, calculations of base area and weight of water, and neglecting the weight of the container, calculate the pressure exerted by water in a uniform cylindrical container on a leveled surface or table in Newton square meters or pascals.
Okay, Faith, a minute there. So for, Angel has 1.783. Okay. Anyway, okay, before the task 3, 9 is very important. 9 is very important, okay? After finding the weight.
Excuse me, teacher.
Yes, please.
Excuse me, teacher. I've not understood.
From where?
From the volume.
Volume?
Okay, I think I can repeat for her. I guess I can repeat for her. Teacher Jose, can you help me reshare your screen so that I can take them through from procedure 7?
Okay.
Because when I go to the chats, you're not using a phone, you lose the screen shared. So you help me reshare again so that I can take them through.
Okay, no problem. Right there.
Yes, from the beginning, now Chloe is asking, how do we find the height? We started by measuring the diameter of the container that we are having. We measured the diameter. Then after measuring the diameter, we named it D in centimeters. After getting the diameter, we used the diameter to get the radius. Our friend here told us that we get it from Radius is equal to diameter divided by 2. Then after we got the radius, we got this cylindrical container that we had, and we poured their water up to a certain height, h. So the height, Chloe, we were asking, how do we get the height? The height that we are using is the height of the water that you have put there. The height of the water that you have put from the bottom to where your water level is. That one is our height of the water determined. Then after getting the height of the water in centimeters, convert it to meters, because we want radius to be in meters, and then height also, after you have got it in centimeters, convert it to meters, so that the volume that we get from pi r squared h will be in meters cubed. Hope you are there with me. Those ones who are asking, what are we on? What are we finding? You get your volume from pi r. We know the r already, the radius that you got, and the h is the height of water that is in your container that you have measured in centimeters, but then converted to meters. So after getting the volume V in meters cubed, please, volume must be in meters cubed. After getting your volume in meters cubed, we are going to use that volume and the density of water, which is 1,000 kilograms per meter cubed. 1,000 kilograms per meter cubed, that is standard. It is the density of water. So the volume that you have and the density of water is going to give us the mass of water that is in that container. How do we get mass? If density is equal to mass over volume, it means that mass is equal to density times volume. So the density that you have is 1,000, and then the volume that you have is the one that you have got from your calculations. So then you will get the mass in kilograms. After getting your mass in kilograms, Teacher Jose told us, you change it into a force, or you change it into weight by multiplying the mass that you have got times the acceleration due to gravity, which is 10. And at that time, you will have found the weight of the water. So that is where we stop and we get the weight of the water. Then after getting weight of the water, we will be able to find other things. Now, Maxi Ivan, you are telling me that you are getting your mass as that 1,340. 1,340. That one is too much for us, for what we remember. I told you on your calculators, the volume will bring 1.34 times 10 power something. So don't forget that power, please. Because if you forget that power, you are going to get water, which is too much. In fact, if I ask you to carry the water which fills 1,340 kilograms, you won't be able to carry it up. So please don't neglect those ones. On your calculator, if it brings times 10 power something, sometimes it is small up there on your right hand side of the calculator. It is there up. It brings there 1.34 times 10 power something. You have to look for it so that you get a correct volume in meters cubed. That is if you converted both the radius and the height to meters. Teacher Jose, I think you can take
yes.
From there.
Thank you, Teacher Peter. I dropped again, sorry about that. But thank you for your clarification right there. I think we need to move forward.
Yes, but these people are getting masses that are scaring.
Yeah, by the way, some masses, maybe they are forgetting the powers there. Okay?
Yes, powers. Please make sure you have put the powers correctly.
We said, yes. I don't think one can have water. One can pour water.
Maybe
the means used such that the mass is in 10,000.
Chloe. Okay, let me use Chloe as the Chloe, I want you to send me in the chat, send me your radius and then the height of the water in centimeters. Radius in centimeters and then the height of the water in centimeters also. Then I'll be telling you which mass you have to have here. As Teacher Jose, you continue. Let Chloe do that for me. Or the one who has taken a BC. Okay. Okay, then Teacher Jose, you can go on as I help Chloe calculate the correct volume that the correct mass that we expect.
Okay, thank you, Teacher Peter. So as we said, after finding the weight, and then if you know the base area we calculated earlier, I think that was it was activity of procedure 5 there. So after finding weight, getting mass time was 10, then divided by the base area, which we calculated from pi r squared. Then you're able to find the pressure right there for 9. Now, friends, we have gone through all these steps because we are going to need them for the other activities we are going to do this afternoon. And because we have gone through them thoroughly, we shall be a little bit fast for other activities to do. Okay, Faith. Was it Faith? Yes.
0 point.
Let's get to task 3.
Using your measurements of diameter and radius, calculations of base area and weight of water, and neglecting the weight of the container, calculate the pressure exerted by water in a uniform cylindrical container or on leveled surface or table in Newton square meter or pascals.
Okay, thank you, Faith. Now, remember the bucket you're using of glass has some weight, okay? And when you add the weight of the glass or container, cylindrical, and then water, you have a total weight. That's why we are trying to neglect now the weight of the container such that we deal only with the weight of water. So that is an assumption as we experiment this in that case. So it is a task for you, depending on what you have used, okay? All the measurements you have been obtaining, the diameter helped us to obtain radius. Then after radius, you obtained area. Then we went to obtaining mass from density and volume, okay? And then weight from mass times acceleration due to gravity. Someone in the chat is asking, how do you determine, how do you find acceleration due to gravity? Okay, Arnold, we can determine acceleration due to gravity, or we can calculate for it or prove for it, but that is above your level for now. But because it is above your level, at all level, we give it as a constant, meaning it should be known. You don't need to prove it or calculate for it. It is given as 10 meters per second, right there. So when you reach, squared, 10 meters per second squared. per means you're having seconds in the denominator, but we shall come to that when you come to motion. So when you want to prove it, that will be A level. That will be A level. So hold on for now. I will look at that later. Yes, Ivan, that's it. 10 meters per second squared. Okay. Then task 4 is for you to upload what you have been doing there. After calculating, depending on what you have or used, and at task 3, then you take a clear picture. The document I attached in WhatsApp, the link is live. You can just click on it. It will take you to the Padlet where to post. So for now, first take a picture, then we shall post later, because we need to move now to this scenario. But this is a continuation of what you have been looking at. Because you know already the other steps, then this will be very easy. So someone read for us that heading. Yes, please.
Teacher Jose.
Yes, please.
Now I used Chloe's radius and height. And her answer has to be 0.3742 kilograms.
Okay.
Not 3,742 kilograms like she has. So the problem is that on converting, she missed the times 10 power negative 4.
Yes,
I think
that is very important.
So if she uses that one, she will get 0.3742 kilograms, which is reasonable. I think it's the same to Max Ivan. I think his mass must be 0.13, according to what he has used, 0.1340 kilograms.
Okay.
Just the calculations on their calculators, they usually miss times 10 power something.
Yes, our friends here should note that in senior 1, they looked at significant figures. So your scientific calculator is
scientific notation.
Yes. Yes. Sorry. Scientific notation. Sorry about that. Scientific notation. So you always have something like this. It will always give your number as maybe A times 10 power something. It can be negative, maybe N, or you can have B times 10 power positive N. So this is the scientific notation we are talking about, the two cases. So you should take note to include as well the powers right there and the tens. Okay. Thank you, Teacher Peter and everyone. Okay, let's proceed to now page 4. Page 4. Someone, but technical hand is up. You can unmute for now and submit if you have any concern. Click on the mic and open it. You might be saying something, but we don't hear you. Okay, before Tekino, let's hear from Teacher Doreen. Teacher Doreen?
Yes, thank you, Teacher Josie. Depending on what you are talking about, the scientific notation, those people, I think it is better also we tell them how they should place their calculators, because we might talk about them like 10 times, like times exponent something, and then they don't know how to place it on calculator. I used to get those scenarios during the normal classroom, whereby people they never knew how to place their calculators to put those things there.
Okay.
Yes, we have a calculator somewhere.
Okay, let me maybe go through that very fast. Okay, so if you're having a scientific calculator, my friends. I talk about Casio, FX 100 ms or 991 ms, such calculators, okay? You always press the value as it is, okay? Say if you want to type what? You want to type, let me write here. If you want to type 2 power 4, okay? Then on your calc, you will press 2. Then there is that big button. It has replay and copy. Then below it, there is a button having that, and then the root of X. So that is the button we use to indicate power. So when you press that button, it will bring the notation or icon right there. It will type a power, and then you press the value you want, F4. So when you press an equal sign, of course, it will give you 16, which is the same as a 2 power 4. Now, if you have a value like 2.134 times 10 power negative 3, and you want to use it. So in your calc, you press 2.134, okay, times, like the way it is, times, you know, the multiplication sign after delete, the below the after delete, and then 10, then to include this power there, okay, to include that power, you will press again that button. You press that button so that you have now 2.134 times 10, then the power button. Now, sometimes or some teachers will advise you to create now brackets, especially you can have fractions, the powers in fractions. So you can create brackets. The brackets are there as well. Above 8 and 9, there is the first bracket. You press it, include a 3, and then press equal sign. It will give you that same value you have above there. So that's how you can just type them easily, like that. You don't need to do a lot right there. Okay, friends, I think we have very few minutes. We need to proceed. There. Someone to read for us the heading we have there. Someone to read for us.
Tracy has risen up the hand.
Okay. Tracy? I don't see
that, but she went, I think, outside.
Okay, anyone ready? Please read for us. Hey, Tracy.
Pressure in fluids.
Okay, first of all, what are the examples of fluids? If you know any, before we proceed, by the way. Anyone? Gift? You want to say something?
There is water.
Okay.
Milk.
Water, milk, and juice.
Okay. But and Okay, I had water and milk. Okay, you should as well note that when you talk about fluids in physics, you don't mean to say only content in liquid form, okay? But fluids, we mean to say liquid form and then gaseous form. So all the money you have right there will be under fluids. Okay, someone read for us that scenario. Anyone ready to read for us? Okay, in the chat we have Vanessa said air, a juice, Docus, blessed soda. Okay, that's good. But for fluids, we mean to say the liquids, to encompass liquids and then gases. Okay, Tracy?
During the lockdown, one of John's work as a son in one home is to sweep and clean the kitchen. This kitchen has ash and dust since it is not cemented. On a bright morning after sweeping, John observed dust molecules in space. He immediately got a uniform cylindrical glass with negligible thickness and tried to contain the dust observed into the glass.
Okay, a minute, Tracy. Friends, I want you to think about that scenario. If you're sweeping and then with light rays or beam incident through maybe a small wall, can always see the dust particles moving in air colliding with each other. So when you try to get a glass to contain them into a glass, they will fill up that glass to its height. So that is what we are looking at. Try to think in that area, and then we look at the questions. Question one.
If the glass is of height h and radius of its base r can be obtained, using the glass base area equals pi r squared, volume of air molecules, density of air molecules in brackets dust, pressure, acceleration due to gravity, g, and pressure equals weight over water over base area. Are you able to obtain pressure equals HPG?
Okay, so I wanted you to look at the other scenario and then we relate it with what you have been doing. Say if you're having water in that case, if you're having water in that case. So remember for the other activity one, we had measured the weight and then we had the area. But as well, there's that formula of the height and then rho, where rho is density, and then acceleration due to gravity again. So are you able to relate the two? But considering the cylindrical container we have, okay? This is what really happens. You have the area as that of the base of the cylinder, remember? And then we have volume. If you have height, sorry, this is volume. We just get the area, base area times the height, which you called H right there. But remember, we can as well, if you have volume, we can as well obtain mass. We can obtain mass if you know the density. This time we are using water because we know its density. So the mass in that case will now be the density times the volume. We looked at this already. So try to substitute. Try to substitute that in there. Say that we have the density, and then the volume is pi r squared, and then h. But as well, we say that if you know the mass, let me hope you're following, friends. If you have the mass, you can obtain the weight, which is W, from mass times G. So again, substitute. You have the mass right there, and then G is known. Substitute, so that you have mass, but our mass is rho. Let me remove this. Our mass is right there. Our mass is right there. So it will be rho, and then h. Okay, let me bring h closer there, and then pi r squared. Are we together, friends, right there? Need to hear from you. Are we together?
Yeah.
Okay. Okay. That's good. So because my board is very small, I need to first remove these above. Remove these above because now we don't need them. Yes, please.
Benjamin is lost. He's lost.
From where?
I don't know where he's lost from.
Maybe you can unmute and tell us. Benjamin, unmute. Step 2. Okay. Let me repeat. Maybe slowly. Let me remove all this. You say that I said that earlier. If you have your cylindrical container, okay, you can measure the diameter as we did. From diameter, finding the average or mean, we got the mean diameter, and then we got the radius. Okay. Now to find the base area for a cylindrical container, we used this formula, where R was the radius there. Okay. Then from radius, we went on to add water. So from obtaining area, we went on to add water in the container to a given height. So in that case, we are able to obtain the volume from area, base area, times height. Okay, but we know already the area. We know the area already as pi r squared and then h. Is that okay now? Okay, if that is okay, from volume, we went on to obtain the mass of water, and we assumed some concepts there. But we say that if you know the density of water, and then the volume, the density of water was given as 1,000, and then the volume, which you have obtained now, you can substitute to have rho, which is density of water, and then volume is there. Substitute. It will be pi r squared and then h right there. So after obtaining mass, we can obtain weight. But we said weight will be mass times the acceleration due to gravity. And then substitute. You know the mass already, acceleration due to gravity is the constant g. And then substitute to have rho pi r squared and then g. So that is where, sorry, there's h as well, sorry. There's h as well from volume there. So that's where we had stopped. And I said, let me first get some space right here. Let me get some space right here. We have very few minutes. Okay, from this, after finding weight, then we come to the formula we know for pressure from the start, from lesson 1, we say that pressure equals force over area. But this time we have the weight. We talked about this already, how this transforms. And then over the base area right there. But we know that the base area is pi r squared of the glass or container or anything that you used. And the weight is what we have right there, okay? Then substitute. You will have rho, H, G. I'm just bringing these together, but I'm getting them from the formula of weight there. And then pi r squared over the area, the base area of your container cylindrical, which is pi r squared. So you can easily see that if you have your water in that container, this will cancel out. It will cancel out clearly. It will cancel out clearly to have your pressure finally as rho Hg, where rho is the density now of water or any fluid you have contained in that container, and then the height which it has risen, and then G, which is acceleration due to gravity right there. So our task now is to go to that question 2, and then use the information we have above question 2 right here. And then we repeat what we did, but using now the height of water, the density, and then acceleration due to gravity in that case, okay? So you will feel that we have very few minutes. Someone to read for us the note. A note. Someone ready? You read for us, Tracy?
Take a clear photograph of your solutions and post it under Senior 2 assignment hand-in Padlet using the link below. You can as well present your work using PowerPoint presentation.
Yes, that's when we reach a point of presenting our work in the Padlet. Thank you, Tracy. Okay, moving forward, and this is the last bit of this afternoon. Please read for us the relevance.
With these concepts, we are able to determine pressure of fluids at a given height h, obtain pressure exerted for bodies in contact with assumptions. Caution.
Okay. So that is to explain why we are doing all this. Why are we doing all this? So you can be asking yourself, why is it that when I add water in a jerry can, okay, it bulges outside? Or when I carry it, when I put it on my head, why is it that I feel it is very heavy, depending on the water I have filled, okay? So those are the questions we are answering now, right there. But the question is very important, especially after this activity, especially with all the materials we have used. So please read for us the question. Tracy, do you still have you on call?
Please remember to dispose of all the materials used in this session.
Okay, so if you used a jerry can, you used a glass, you used water, remember to clean them very well and place them where you got them after using them. And then lastly, the end is there. Stay well and please stay safe. We have a minute here, but let me take this opportunity to thank you, friends, for coming. Thank you for attending. I thank the teachers who have been on board. Teacher Peter, Teacher Kalema, Teacher Dorin, and then other teachers who are here as well. Thank you for everything. And our friends here for attending. Please endeavor to do that work. And please join our WhatsApp groups to have all the updates. I shared the copy of this and there are links, the links right there. So you can always click on them and then they will take you right away to the Padlet. Yes, Benjamin, if you did the other work as well, the one we had to do on Friday, please post it as well. There's a section, let me take you through maybe briefly in a minute.
Don't have time.
Yes, in a minute maybe. In a minute. When you open your Padlet, come to Senior 2 assignment handing. Click there in the picture where you see the beautiful folks there. Then it will load as well, depending on the network. Then look out for that day's section. So last Friday was 27th, so you post there. Click on the plus sign and post. Today's work, 30th August, you post there as well. Thank you, friends, for coming. We meet next time. And a blessed evening.